No cam stream today. So let me just turn this off. I'll just leave the overlay there. I don't really care so much about that. Um, so we're doing 2022, or we're gonna try and do day 10, I guess. I have not had any luck doing any of these in the past 4 days, so we'll see. Um, I legit don't have any idea what's wrong with my code from yesterday. I think there's an edge case somewhere that I need to basically test for and fix. So we'll do that when we can. So we're gonna have a day 10 dot test dot text. Um, okay, and then we'll also just create. Well, we're gonna download it, so let's not do that. Um, we do want day 10. Let's put it here for now. Well, actually, no, that's fine. Stay over here. Okay, then let's get rid of that. We'll go to our main and we'll create a package. Nope. Package called day 10. Oh, it already exists. Lovely. So, uh, day 10, new day 10 file, add. Okay, now put this here. This can go here as well. Then we're gonna write a suspended function called day 10. That's just going to do nothing at the moment, but we'll quickly add some stuff in here. Okay, so the basic idea is there's like two operations for like this stack machine, I guess. And so we just need to like read these things and then parse them out and do something with them. So we're just going to parse the lines first. So we need a no-op parser, which is going to be a parser, and bring in Combini, all of it. To parse a no-op, we're just gonna say string noop, and then we need like a sealed class called operations. And basically it's gonna have an object that's a noop or no op, whatever you want to say. I think noop is funnier. And we're gonna have a data class called an add. Let's just call it add x because I don't know if there's like something we need to do. Value, and this is just gonna be an integer. Okay, so here we're just gonna return a noop if we parse a noop, and then we're gonna have add x parser, which is going to be a parser of the string add x followed by white space followed by an integer. So value integer, and then we'll return an add x with the value converted to an integer, like so. Okay. Then we need to read in our path, which is going to be a colon.io path from input files, day 10 test text. And then we can just like run our parser over the files, which is like pretty common. So these are going to be like our operations. And we're basically going to say lines of path. And we're going to parmap our parser We're going to say L. That's our line. And then, yeah, we can just take that in. And we need that. So our line is going to say, like, when val r equals... we also need a val operations parser, which is basically just one of... this needs to be parser, and it's going to be one of new parser or add x parser, like that. And so then we can say we're going to start with our operations parser, and we're going to parse the L. Okay, if we are able to do that, so parser result okay, then we're just going to return the result. If we have parser result error, then we're just going to throw an error, unable to parse line L as operation. Oops. That is not the right syntax. What? Oh, well, parser operations. Okay, maybe you don't write this and you just write this. Oh, I understand. I think I understand what's going on here. This needs to not be a parser noop. It needs to be a parser operations, I guess. And then this complains? Why? Oh, I totally forgot to, like, combine these things as part of the sealed class. That explains a lot. I probably don't even have to write this now. See, this is what happens when you need extra syntax to describe your sum types. You goof it up sometimes, but it's no big deal. We got it done. Okay, cool. So, okay, apparently I do need is, and then we should be good. And then we can basically just collect these things, and just to make sure we did it right, we can print them. Okay, so our main function should have J10 in it, and we can clean that up, and then we can just hit play. Oh, also we need to say at low preview experimental coroutines, because so for ParMap we basically need both of those things. Ooh, excuse me. Okay, so we have a noop, and we have an add value, and that. Okay, so we've parsed our input. Now, each of these things, okay, so at the start of the first cycle, the noop instruction begins. So we start at 0, and we do nothing. At the start of the second cycle, that's 1, add x instruction begins, and then it will go through 1, 2 cycles, and then do its action. Okay, so we need to know, like, the state here. So we're gonna have a data class of like, I don't know, execution, I guess. And this needs to have like ticks as an integer, and it's going to hold a value as an integer as well. Well, let's just call this part 1 state, because yeah, something like that is fine. We know that the value we can initialize to 1, so we'll just do this. Okay, so then from here, we're basically going to fold over our operations onto a execution state of 0, basically. And then we're going to do something with our execution state and something with the op. So for now, we'll just do that to make it compile. Oh. Okay. Okay, so now we need to describe what our operations do onto our execution state. So we're going to have like a function called noop, and noop is going to take an execution state and return an execution state. All noop does is increment a counter. So I think we can make some optics for this just so we don't really have to like write like any code, because that's convenient. So we're gonna basically take our ticks and we're gonna modify the execution state to add 1. Okay. So I think we just need to hit play again. Oh, right. So to do our optics, we need to have companion objects so that we can create this ticks thing. And then I think after we play this once, it should be smart enough to figure it out. Yeah. So I have something in my... Okay, so the way the optics work is I think that it's like writing companion objects to the execution state through this plugin called KSP. And then like if we go look in, not here, it's in generated KSP, it will like generate the optics here. And then it will allow me to use them because I have something in my Gradle thing, this thing. Yeah, so there's like this idea plugin which can tell idea to like go look for these things. I basically just copied this from this page right here. Okay, cool. So we have that, and so we've described the noop operation, and then we're going to have the add x operation, which is going to take an execution state, return an execution state. And we need to modify kind of 2 things here. So first we need to like run the ticks. But actually one thing we need to think about, well, let's just do the action first and then we'll deal with the ticks part next. So we're going to have like what is it? Ticks. Updated ticks. So this is going to be execution state ticks modify. Oh, we can like just write a function. Oh, but yeah, it's fine. Execution state it plus 2. Right, so in the updated ticks case, we do this, and then what we're going to do is say execution state value modify the updated ticks. Oh, this also needs to take the new value. So this is going to take an add x. Add x. Okay. And then we're going to modify it by adding the add x dot value, I think. And then all we need to do is basically pattern match on our operation when up. So for the object, we just say noop, and then we run noop on the accumulator. And when we have add x, it'll be like is add x because it's a data class. We'll run add x on the accumulator with the op, I think. And then this will give us a result state or a part one result, I guess. I don't know. I haven't been able to finish part one for the past 2 days, so it feels weird. Oh, actually, one thing that's kind of neat about this language is there's like cool goofy functions, like for example, dot also, println it, and so we don't even really need to like. This is like perfect for something like this because it's just kind of scripty. So that's like basically what we want to know. We should have 5 ticks and a value of -1. So 5th cycle. Okay. And so then 1, 2, 3, 4, 5. Yeah. So now let's grab this like example. And we'll put this in here. And then delete this. Okay. So now that we have this, we also need to, I think, add something to our execution state that basically tells us which signal thing we're on. Because like maybe you could learn something by looking at the value of the X register throughout the execution. For now, consider the signal strength. The cycle number multiplied by the value of the X register during the 20th cycle and every 40 cycles after that. 20, 60, 100. Okay. So like I need to know if I'm 20 or if I'm mod 40, I guess. Okay, so here we're just gonna say like fun signal strength, and this thing's gonna take the current tick and the register, which is also an int. And then we're gonna say if this thing's gonna return int possibly, I guess. So if tick equals 20 or tick, wait, it's every 40 cycles after that, so you can't just do that. Oh, that's so annoying. They did that so you can't just use modulus, right? Although maybe there's some interesting modulus math I can't think of at the moment to make this work. I guess we could just subtract 20 if it's greater than. So okay. So if the tick is equal to 20, then we want to do the math, which I think is just the tick times register. Else if tick minus 40 modulus 40 equals 0. Tick register. Else null. Oops. So I assume that this is the right thing, right? So if we take 60, subtract 20, that's 40. We take 100 minus 20, that's 80. So yeah, it seems like that should work. And we can probably make this an or. Tick minus 20 mod 40. What happens if this is 0? So tick is greater than 20 and tick minus 20 mod 40 equals 0. Right? Like, I don't want a mod with 0, so I just want to make sure it's like actually in the right range. Why are these vals red? Oh, I don't need them here. Not a data class. I got my COVID booster last night, so I'm a little hazy at the moment. Okay, so that allows us to determine the signal strength. We need to determine the signal strength and then like append it to the execution state. So we're gonna have a val. Actually, let's put this second. So, well, no, we can just put it here. So val signal strength. And this is going to be a mutable list. Let's just make it a mutable list because I'm lazy. And we're going to initialize it like this. And I bet you this code will get cleaned up if I just do that. It does not. Okay. All right. So if that's the case, then basically we're going to say prior to this thing, we're going to do the following. We're going to say the execution state dot oh, we can actually make this a companion object of the execution state. Yeah. Yeah. Okay, so we could say execution state dot signal strength, which returns that. And so then we can just say if ticks value. So it does implicit this is because it can. We also don't need this run. So that's like the signal strength for the current execution state. And so we can say like execution state signal strength. Except this needs to be like signal, not signal strength. So we're going to say like if this is non-null, then take Okay, so we're either going to take the new strength and add it, I guess. So execution state dot signal dot it doesn't give me any helpers here. Maybe if I like just say like please go generate the things. Okay, and then maybe here we can say that. And then we're just going to say execution state dot. Oh, we have to do this with list. So I imagine there's mutable list dot add or something. Okay, whatever. I think we can just do execution state dot signal dot add, and then the it. And then we can just modify this because it's going to happen before the ticks. Now, okay, so I think that works for the Noop, but it does not work for this one. For this, we need to do each of these separate. So we're basically going to do this twice. So 0 until 2 for each. We don't really need the value, but we do need to do this twice. So the first thing we're going to do is try to update our signal strength. And then we can just like do our update. Except instead of 2, we're going to do 1 because we're going to update 1 at a time. Right. So this will do the right thing, but this does not. Because we need to like read through the execution state. Okay, so we're gonna fold on the execution state, the accumulator, and this thing. Also, we'll be able to get rid of run here. Okay, so first things first is we need to see if we can update our signal strength, and then we're going to update our ticks, and we're going to do that. Okay, so that does the proper fold, I think. All right, what does this do? I don't know what it's going to do. Okay, so let's see. Does it get the right thing? Nope. Man. Okay, let's go back to this one. Oh, well, that's not long enough. So we want to just get like the first 20, I guess. So Wait, how many? So this is 2, 4, 6, 8, 10, 12, 14, 16, 18, 19. So I think this is like the first 20. And then we should get 1 signal strength out of it. So let's see if that works at least. That gives me 800. Which could be a few things. It could be that actually 20 is not the right number, and or like we just need to start at 1 instead of 0. What if we do that? Does that change anything? So it's 840. What was the number? What was it supposed to be? 420. So the signal strength during the 20th cycle. Okay, so we should like... So cycle is ticks. Register is a value. And then we want to print result is ticks times value. Doop, 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 doop. Okay, so it seems to think that the register is 40 at the moment. So how is that possible? Calculator. Really? Okay, so 15 minus 11 plus 6 is 10. Minus 3 is 7. Plus 5 is 12. Minus 1. Minus 8. Plus 13. Plus 4. So that's the 20. So it's must not be doing the negative numbers. So what's 15 plus 11 plus 6 plus 3 plus 5? So that's, well, that's not even far enough. So I don't really understand what it's doing. Okay, let's so the new register is the result, oops, result dot value. Oops. Oh, it's updating every time. I'm dumb. That's why it's double. So, we only want to update the ticks and then like the signal and then do the thing. So this needs to go outside of this loop. And this is just gonna this thing is just going to tick the thing. So this is gonna have a val updated ticks like this, and then we're going to return the addition like so. 2021 420. There it is. Okay, that makes more sense. It was just an order of operations issue, so I think that will get us there. So I think we can also probably just comment that out, and I think we already got rid of that, so this should do what we expect it to now, I think. Okay, so let me grab this larger program, and then we will put that in there, and then we will hit play. Okay, so 1140, 1800, 2940, 2880, 3960. 28. This is what? Is this number? This number can't be wrong, right? I don't understand how I can get almost all of them except that one. Did I like copy something wrong? Let's just delete this again. Man, very annoyed right now. Copy. Paste. 146 lines. 4180. 2940, 2880. Okay, what's the sum of those values? Like, oh, that's kind of nice. Because, like, I'm guessing that those... Oh, it doesn't print anything. Nope. I I legit have no idea how this could possibly be wrong. I don't understand. So I think I'm just gonna literally try this and see what happens because I'm genuinely confused. Day 10 text. Like, hey Joker, how's it going? I feel like I haven't seen you in a while. How are things? Sorry, no cam stream, but my camera is apparently stupid. And I need to buy another cable for it so that I can charge it while I'm using it. Because it doesn't come with one for some reason. I'm still very confused by this. Okay, yeah, whatever. So let's try this, see if it works. I don't know. Yeah, I'm using Arrow. So this is Arrow coroutine or whatever. Yeah, this is Arrow FX. That's the term I'm looking for. I also have some optics in here, so I'm using optics for this execution state, which is kind of probably a weird data class, but because like it knows its initial value, but I guess that's just like a semi group. So or sorry, monoid. It like knows what a monoid of it is. Okay, so I think that we have now day 10.text, so we can just play. I like it so far. I can't say that I really know what I'm doing at the moment. Um, yeah, so like in my brain, something is wrong, but I can't possibly. Can it replace Scala? I have no idea. I've never used Scala. Um, in my mind, Scala was really hard, and I didn't like it very much. So we need to figure out what's going on with this input because it's not right. Oh, I want to print these. This number is not right. It's supposed to be 18. So it should be 220 times 18. I think. Yeah, 220 times 18, but it's 19. So I'm wondering if that implies that I have to. Let me read this. It says during the fifth cycle, X is still 4. After the fifth cycle, the instruction finishes execution, setting X. So does the execution finish in the final? Maybe that's like the trick here. Is this like order of operations is technically wrong? So let's just do this like manually. So or do I have to first update the tick and then assess the signal strength? I don't know. Let's try this too. First tick is way better. First tick. Okay. First tick. First tick. Okay. So that's the first tick. Then the second tick updates the value. Okay. So second tick is going to do this. Update the value. And then assess the signal strength. Maybe? And then return the updated. This is a weird song. Oh no, this is not this. This is new. Okay. So in the first tick, all we do is tick the signal, check the value. In the second one, we first update the value. Like we tick, update, and then do the signal strength calculation. Like that's the only way that I think this can work. What? Oh. Wait, no, that's right. Um I'm pretty sure this is what I had before. Or maybe it isn't. I don't know. Also, why is this here twice? Well, actually, this is interesting. This is very interesting. Oh, I don't need this dollar sign. What am I doing? Okay, so let's do this and let's do this. It's not 120, it's 220. So what's happening here? Also, let's do... Oh, well, we have to update the state first. So let's print the... println execution state equals execution. First tick equals first tick. And then this will be second tick equals second. I don't understand what's going on. So confused. Why doesn't this print anything? Oh, 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 oh. Okay, so that should print these two things at least, I think. I see it. I think we also need to do this. There it is. So, it was actually the order of the noop thing. I need to tick and then adjust, add the signal strength. It wasn't actually this one at all. And just do... Oh, that's not going to work because I deleted this. I think if I go like that, I can do... Yeah. Okay, anyway, this is probably fine because it's just like very trivial. I think that all of this code is duplicated, so we could just pull this out into a tick and signal strength function, which is going to take an execution state and return an execution state. And then this whole thing can just get pulled out into here. Oh, it's just a noop. We can just reuse noop. We don't even need to like write a function. This is just nooping. So we're just going to say first tick is a noop. Second tick is a noop. First tick. And then we just need to modify the second tick. That's way better. Okay, sweet. So let's see if we get these. 1580. It's a different number than I had before. Yay, we did one. Oh boy, this looks scary. Okay, so it seems like the X register controls the horizontal position of a sprite. Specifically, the sprite is 3 pixels wide, and the X register sets the horizontal position of the middle of that sprite. In this system, there is no such thing as vertical positions, okay? If the sprite's horizontal position puts its pixels where the CRT is currently drawing, then those pixels will be drawn. You count the pixels on the CRT 40 wide and 6 high. The CRT screen draws the top row of pixels left to right, then the row below that, and so on. The leftmost pixel in each row is in position 0. Okay, and the rightmost pixel is in each row is 39. Like the CPU, the CRT is tied closely to the clock circuit. The CRT draws a single pixel during each cycle, representing each pixel of the screen as a sharp. Here are the cycles during which the first and last pixel in each row are drawn. Okay. Okay. So by carefully timing the CPU instructions and the CRT drawing operations, you should be able to determine whether the sprite is visible the instant each pixel is drawn. If the sprite is positioned such that one of its 3 pixels is the pixel currently being drawn, the screen produces a lit pixel. Otherwise, the screen leaves the pixel dark. During cycle 2, okay, cycle 1, okay, so our first tick, we don't do anything. So why is this? Oh god, this is horrid. This sounds really cool, but like these instructions are so confusing. The thing that I really am confused about, so this is the combination of like I find this so confusing. Okay, look at this. So why are you showing me this? And then this. And then like a short one and a long one. Short one, long one. I don't get it. I also don't understand even this. What do you mean? How can the sprite be here? Shouldn't it be 2? This is really driving me nuts. Like the CPU, the CRT draws a single pixel during each cycle. Okay, so we draw a single pixel. We draw a single pixel. The sprite is now here. So we draw a pixel. The sprite is now here. So we draw... Wait. So we draw this. Okay, I think I'm getting it. But man, is this confusing. So it's like... We need to know our... Basically, if the current... We're going to build up a line of 40 for a row. And then basically, like, write that off when we're done. Okay. Jesus. Okay, so our execution state is getting a little crowded. But I guess one thing that's kind of useful is I don't really need the signal anymore. Is that correct? Well, I need the signal for the first part, so let's just keep the signal. What I need is another mutable list that's going to be called the CRT buffer. And it's going to be a mutable list of integers. No, it's not. It's going to be a mutable list of characters. And then we need a CRT, which is just going to be a list of character. Right? Like we're going to just write like one line of the screen at a time. So I think these are all the things that we need to mess with when we're doing this. I suppose we could get rid of this mutable list stuff, but I don't think it's actually that complicated there. Ideally, this would be completely pure, but I don't know. Let's see if we can even do this first of all. Okay. So, we know how to calculate our signal strength. So let's just get rid of this because we'll just calculate our signal strength as we go. Okay, so I need to know the size of my buffer. And is that before the tick or after the tick? So I tick. And then I need to decide if if I overlap with my my buffer thing. Okay, so like if the current CPU value Oh, can we use reuse Noop here or no? I think we can. So okay. If our value modulus 40, because like the ticks will be across the thing. Let's give these more meaningful names because this is hard. So horizontal position is the ticks. So the result dot ticks modulus 40, because each thing is 40 rows long. And then what we need to know is, does the horizontal position overlap with the number? I think we don't have to do like, yeah, because this can only go up to 40, I guess is the point. Okay, so if the current horizontal position like overlaps with the value of the buffer, so if it equals the no, not the value of the buffer, that has nothing to do with it. Value -1. Can you say like in list of result dot value -1 result dot value +1 result dot value. Let's just like, so that's like our kernel, our sliding window kind of thing. And so if that horizontal position is there, then we're going to write out to the buffer crt buffer result dot csp dad the a character. So this means it is there. Else we're going to result crt buffer add dot. Okay. I think if our buffer is full, then we need to like write it. It's just like, I know this is like state management, but it's just easier to do this. And we'll like, once we solidify our buffer, we'll leave it like this. Okay, so the idea here is like, if our current horizontal position overlaps with the CPU value. The, what's it called? The register? Write out else if we have a full CRT buffer, like write it to the screen or something. Write to screen. Let's call this screen. We have our CRT buffer and we have our screen. And I think all of this can happen in Noop. I don't think anything has to happen in our CPU cycle code. Determine if we should append signal strength and then write out the result. Okay, so we want to know the total signal, and then we also probably want to be able to display our little thing. Display screen. So that's going to be one of these things. But we can just take a list of. So input is a list of. So we know the rows or the columns. 40. And we actually do know the rows is 6. 1, 2, 3, 4, 5, 6. Yes. 6. And this top part is 0, 0. Okay, so we can just print it out top to bottom. So 0 until rows for each row. 0 until columns for each column. We want to print the input of row column, and then at the end of each row we want to println. Okay, and then here we can also println display screen and then r dot screen maybe. Don't look right. I think it's because of the order operations, but not 100% sure. Let's just make sure it's not like upside down or backwards or anything. No, it just straight up doesn't look right. It gets the first 2. Wait, is this still the right total signal? Was that the number I had? Yeah, okay. That's good. Yeah. So we can't do it in Noop for this CPU. We have to do it after. So I think that means that we have to separate the two things. Okay, so let's copy the old noop into a tick function. Fun signal string. Okay. This and delete this. Delete all of our buffer stuff. Okay. So our signal strength function, so tick. We'll just call this tick. So this does the actual tick. And then we can tick and then do this basically. So this is going to be tick execution state. Okay. Then we can write a function that's like display, which does this nonsense. Display. No, it's like populate screen. And it's going to take an execution state and return an execution state. I think we can do this one. And we're just going to grab all of this and put that here. Okay. So execution state. Execution state. I probably can do this rename reference to execution state. So all this is doing is, yeah, populate pixel. Pixel. Let's just call it pixel, actually. Pixel. Okay, and then we can say, okay, so we tick, so now we pixel, and we're done. Okay, then we tick again, and then we say result, and then we return the result. No, we pixel the result. Pixel. It sounds like pickle. Okay, what does this do? I don't know. Okay, so I want to like make this like really much smaller. Because this, even the first 5 don't look right. So we draw the dot, then we draw a dot. So like this one's wrong. So like why? I don't know. 4, 5, 6. We're not gonna be able to draw the whole screen. So let's just make this like row 1 and just play that. Okay. And then also let's like just reduce the columns to like this many. 1, 2, 3, 4, 5, like 6. Okay, and then that way we can like reduce our input greatly and see what's going on. Okay. So in our test file, can I duplicate? Duplicate? Reload. Okay, I can't really make another one, so let's just make a new file called day10 smaller dot text. And we'll copy like this many things in there. Really, we only need 3 ticks. Oh, this isn't even the right... I'm an idiot. I'm not doing the right file. What I want to do is day10 test.txt. It's still wrong. Nice. Okay. File. Day10 smaller text. Okay, this one. Let's grab. So we just need like 6 lines. Okay, so we have this and we want to open up smaller. We just want to start printing. Let's make sure I understand this. So this is now 5. So then we have register. Okay, so let's just print. Let's just print the whole thing. Okay, so tick value 1. This is before we do anything. Wait. Do we have to also pixel here? Isn't this enough input? What is this complaining about? I'm confused. This worked before I added this print statement. Did it not? Apparently no. Okay, don't display the screen then. I don't need you to. I just need to see this. Okay, so we aren't. Well, that's not good. There's a few things going on here that I don't understand. I don't know if that's supposed to be there, but I'm genuinely confused. Oh, man, what am I doing? So, shouldn't this... Oh, it hasn't drawn anything to the pixel state yet. Jesus. Do this later, buddy. I am dumb. Okay, so value 1, and then let's look at this. So, oh, but this is like the 15 example. So we should grab like the first few files of this one, or whatever. First few lines. Not the other one. Otherwise, we're not going to be able to like compare. Okay, so okay, register 16. So we do blah 1 2 16 dot. In 3 we add a dot. Wait. There's no tick here. So does that imply we do need this? I think so. 1 1. Dude, I am falling apart. Okay. So we pixel the second tick. I guess we can just write it here. We pixel the next tick, and then we second tick. So I think it was the same. It's just I probably did it wrong. Okay, so there's our first 3 ticks. So then we draw a dot. Then we draw this. That looks fine. So let's look at, I guess, more. What's frozen? Am I frozen? Okay, I think this is actually a Firefox issue, which sounds hilarious, but I think that's actually true. So 1 second. I need to kill Firefox. Yes. Terminator. Kill all. Firefox. Okay, so that's there. And then I guess I need to switch back to Chrome because something goofy is going on. I'm not gonna turn on the music again. Uh, I have a headache anyway. I got my COVID booster yesterday, so um, trying to like do my best today. Um, so all right, what was I doing? So these are 40 and 6. Okay, and then what am I trying to do? Okay, I want to change this to this and then hit play. So we can just look at like the first row. Okay. I kind of don't understand this at all. Oh, because I'm a dum dum. I want this one. Gosh, this is so dumb. I'm literally just melting away as a human being. Okay, let's just scroll up here. Need to find. Okay, so we basically our first CRT buffer ends here. So it's sharp sharp dot dot sharp sharp dot dot sharp. Okay, let's just go Google on the advent of code because I don't know. Oh, this isn't even going to display the second one? Oh, gosh. Maybe Firefox won't explode. Okay. So sharp sharp dot dot sharp sharp dot dot. Okay, so it's like a perfect pattern. And so for some reason it's off here. Like this should be a sharp. Okay. Well, why? Is it because where my ticky function? So we tick and we pixel. We tick, we pixel, we tick, we pixel. It's so close. Okay, so we got to go up to wherever we do that screw up. Okay, so this is the screw up. Um the value is 8. 0, 1, 2, 3, 4, 5, 6, 7, 8. So that's like just our overlap being straight up wrong, right? Because if we were at 8, if we were here or here, then this should overlap because we're at the right tick. So something is wrong with this code. So this should be 8. Okay, let's print also our sprite. I don't even really. So like something is wrong with our sprite. I feel like at that level, but I don't know what. Huh? Oh, this might be 9. Uh, okay. Our value starts at 1. So, um, I think that this is not wide enough. Yep, that looks right. Okay, so I think we have it now. So let's just comment this out, and then we can use our display function to display the screen. Okay, and then the second one is just triplets, quadruplets ends in 4, and then fives ends in 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. But the oh no, the next one's right too. Wait, no, it's not. This one's missing this. Otherwise, it's pretty darn close. So I don't feel like finding this bug um, at the moment. But maybe we can just read this. So let's just try it. ELGFKAZ something. ELGFK ELGFKAZ. And then is this just another G? Probably. So I think there's some weirdness around the edge, around this edge for some reason. But I don't really understand what it is. It's probably because well no, it has to be 40, right? So if we switch to this, that's actually a cool problem. That's a really cool problem. So like, but this is right, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sets. 1, 2, 3, 4, 5. Yeah, so there's 10 sets there, and one dot 4 dots, 5 dots. So how is this row screwed up? Like, how is that even possible? I think it means something is wrong in the pixel logic, but like what? I mean, we can try and print it, but like it's gonna be so hard to find that. Let's see if we can, I guess. These things are just gonna be massive at this point because we're just like building out this buffer. I guess we do know what tick this is, so that's kind of helpful. So it's 40 times 5, I guess. 40 times. Seriously. So somewhere around tick 200 is the problem. But I'm not going to be able to read this. So if we're tick 200, then we should overlap. We do overlap. And then, like, our screen on the next one so we wrote, oh, it does overlap, but it shouldn't overlap because there should be another dot. No, 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 that's this one. So wait, what? So it's saying the previous one doesn't overlap. Apparently does. This one does too. This one does too. Oh, doesn't. Right? Because we say the sprite is. Oh, confused. I think we also need the horizontal position. Because I think that actually what's happening is the edge is wrong. It's just I happen to be lucky. Yeah. So we start at 1 and go to 0. That's not really what we want. Don't we want this actually? So 0 to what? Wait, why is this? Oh, because we. Huh? Why does this only go to 35? Oh, probably because we only tick. That's confusing. Okay, anyway, let's see. So this is 40 to 0, which is probably what we want. Except now this is actually the right thing, I think. Okay, and then let's get rid of this print statement for a second and try and run this again. Nope, that math is not right. So the horizontal position here is supposed to be 39. This should be 0, right? 0. $39. Yeah. So how do we make that happen? So this one's 40. Um, confused again, but let's just look. We'll figure it out. Okay. Oh, right. Is it just this minus 1? What's the final one? The final one is 0, though. So it's like, how does this math work? I'll get it eventually. I think it's because we start at 1. For some reason, my brain is dumb. Then we should end at 39. Okay. And then, do we do the right thing? Yes, we do. Okay. There we go. Gosh. Because we start ticks at 1. Just dumb. Okay, I'm glad we're basically done with this because my head is really hurting. And there's that clean G at the end. Um, to give you your final result. I'll paste this into the chat. Readable. That's actually pretty amazing. This is really actually a really cool problem. I kind of like it a lot, but also it's just like one of those things where you're like off by 1 errors are really brutal, and I had a lot of them because I just wasn't thinking about this. This like it makes perfect sense when I like sat here and I was like, okay, something's wrong at a boundary, which is like 100% and off by 1 error. So I just needed to figure out where it was, and then yeah, we need to get this to 0 is the point to start, and so that's how we do that. And one thing that's kind of interesting here is uh we tick and then pixel, which I think implies that we can actually inline this, but since we have this separate, we'll just tick and pixel separate. I think that's totally fine. The other thing that could be interesting is to see if we can get rid of these mutable lists real quick. Let's see how difficult that is. Because there's a lot of like side mutation happening that I'm not a fan of. So this is just this stuff. Okay. So let's see if we can get rid of this and just deal with that. So, okay. Now, the problem here is that if we do this, then we have to return a new result. So we really want to return the new result if we can, or we want to return the result. The Elvis goes the other way. So like it's going to be something like this. And instead of this thing, we're basically going to say execution state dot what is this thing? This is the signal dot modify, and we're going to modify the result and say it plus so list of string and delete the rest of this. The signal is an empty list. So we want to take the current signal. Why is this a mutable list? Why does that matter? What? Oh, maybe I just need to like go through the rest of this and deal with it. Yeah, okay. God, this gets so nasty though. I think the buffer I like don't want it. I think the signal is actually easy to fix, but I think this is actually way hard to fix, and I changed my mind. If we wanted to do this like really, really quote unquote correct, then we could do. I don't want to do it correct. I want to stop streaming because I have a headache. But this one's easy to fix, I think. I wonder if like we just create like a bug and then just like stick. Yeah, I mean, why am I writing Python all of a sudden? What is going on? Yeah, see, you can see like it's time to get out. There we go. There's our pretty value. So that's right. Okay, how would we do this? So we would have to return. Okay, so here we'd have to return a new state. So we would say like write the thing and then clear the thing or like page the thing or something. We can do it. We can do it. Come on, me. Focus up. You can do this. Why does it do this by default? Like I've told you what the type is, so you don't need to like. Well, I guess this does say I can just do like list of character, and then I don't have to like write list of character. And same thing is true here. It just saves me like a few characters. So let's do that. This is int. Are these complaining? An a type annotation is required. Oh, well, here we are. It's not going to try and refer this. So this is a list of character. This one car. Just delete these because yeah, this is a data class. It's like it has like a initialize. It's kind of like a mempty setup if you wanted to call it that. Okay, we can focus up. Let's do this. So we're gonna say like fun, right, bright, and we just need to know the horizontal position, which is an integer, and then we need to know the sprite, which is a list int, and we need to know the execution state, and we're going to return new execution state. Then we're going to take all this here. We don't need this run anymore because it's just a single if statement. And then we're going to say here is going to be execution state, CRT buffer, modify, execution state, and we're going to say it plus list of sharp, like that. And this one, I'm going to do something very similar. Instead, we're going to add a dot. Okay, I think that will like stop complaining when we get there. So here we're going to say with buffer update is going to be right sprite, horizontal position, sprite, and the execution state. Okay. Then we need a function that's like page. I don't know what that would be called. Like page monitor. And for that, we just need to know the execution state, it looks like. And here we're just going to say like if execution state CRT buffer size equals 40, then we need to modify the screen. So the screen by execution state, and we need to say it. Oh, this is interesting because we actually have a list of list here. So how do we do that? We want to like append list to list of list Kotlin. I don't know how to do that. Is there like a insert interleave? How the heck do I like put something into a list? Like I have, so it is a list of list. Kotlin list operation. add, but that's a mutable list. I don't want a mutable list. I want a I guess I have to create a new list in this case. So I'm not going to do that one because I think this is actually a pain. Like a weird kind of pain that I don't feel like dealing with. I keep saying that, but then I walk back on it. Okay, let's see if we can do this. Let's just write this function. Oh, I have a headache. And so that's why I keep doing this. Because I want to finish, but also like I want to do this the way I want to do this. So this is like append list. And it's going to be on a it's going to be a generic function on T, and it's going to be a list of T, and we're going to append a new list to it. But it's actually sorry, it's a list of T, and then we want to append a list, which is a list of T, and then we're going to return a list of T, right? That's what we're going to do. I don't know what this is complaining. Okay. So we need to like basically say can we say this plus list of L? Is that all it is? Oh, wait, what am I doing here? This is not where I want to change this. This was fine the way it was. Oh, no, no, no. Oh, geez. Okay, that's fine. This is supposed to be it plus list of sharp, like this. And then here is where we want to append list the buffer. So we want to know the execution state dot CRT buffer. Okay, and then if we're not going to page the monitor, then we just do this. But we also need to modify one other thing. So this is actually going to be like with screen, or like with screen right. And then we need to return the execution state dot CRT buffer dot modify empty list. And we need to modify the with screen right. I thought that's how you did that. Let's just like give it some hints. Oh, right. Okay, so here we need to with screen equals page monitor. I think we should just call it screen. And then here we want the with screen. And here we also want screen. This is going to be, let's just call it right. Right buffer. Okay. And if we did this right, we didn't. And I don't think you need. I didn't think so. That seems right to me. So something in our display screen appears to be wrong. So what if we just comment that out for a second and just see if this thing still runs? We get 15880. So just turn the debugger on. Look at look at the first few. Because it's way easier to see the patterns here. Just see if we have the pattern. Very interesting. We have the sprite. We need to. Oh, okay. So let's see. Wait, no. I think somewhere we're not calling right sprite. Because this is like, this should have two things in the buffer at this point. If modify the execution state. Add that. My little kitty's hungry. I think it's like really close. It's most definitely right sprite. Yeah. Before fusion state, after with buffer update. And then comment this out for a second. So close. Cool. Yeah, it like isn't doing anything here. What? Why not? Why doesn't it do anything? This. Hey, Hotzenbots. Hey, Magic Mud as well. No, I'm not doing a Haskell. My my whole goal when I'm doing, sorry if I missed this. It's been like 5 minutes. Looking at the yeah, my head kind of hurts. Um, I usually do admin a code to like learn new things, and so this year I'm trying to learn Kotlin, and it's okay, I guess. So something is wrong with this function because it we don't do anything here and here. Like we get a ticks and then our CRT buffer here is empty. Yeah, it's I mean I actually kind of like the language. It's just like I don't know what I'm doing in this particular case to cause the problem. Like it seems to me like always in this function I should be updating I should always be updating the sprite or the buffer rather. Like we modify the CRT buffer and append something to it. So like the CRT buffer is like not getting appended in some cases, but I don't understand how that's even possible. So we have the horizontal position, we have our sprite, and then we feed those things. We don't modify our execution state when we pixel. So we pixel. Did I like delete a tick somewhere? Oh, actually, I could literally also just wrap this in pixel. Oops. And for some reason, we're like skipping sprite rights. I don't understand what I did. Wait, It's working now. What? Didn't do anything. Did I? I don't know, man. I'm too tired for this. Okay. Anyway, we've made this completely pure, I think. So this was actually a really cool problem, but holy cow. The off by one error killed me. Well, I don't know if it's right. Let's double check. So we have this function to like display a screen, and then you can see the screen is like this, and this is correct. So here's like, I'm turning this crazy CPU instruction file. Not this one, not this one, this one. So there's like a bunch of these CPU operations, and then you basically apply these CPU operations and turn them into a CRT monitor. So this is like a monitor of 40 characters wide by 6 characters tall. And then you like do this really ugly state mutation um, and write like these things to the screen, and then you can display them. Now, the actual answer should be this one, and then if I play this thing, you'll see that it kind of prints letters to the screen. Probably kind of hard to read, but anyway, this is a P, an L, a G, an F, a K, an A, a Z, and a G. So that was the like what we were supposed to get at the end of the day. And so there's a lot to get us there, but um, we figured it out eventually. So yeah, and we made it like actually pure, which is super cool. Like every piece of this is pure. There's no state modification whatsoever. Well, I mean, it is modifying states, but like you always have you always are turning one state into another state, and you're never mutating the state. So yeah, that was actually pretty fun, I guess. Um, it's kind of interesting. I like this one because you can like you write the first thing and then you're basically just adding something to it. You don't have to like you don't have to what's the word? You don't have to write like two different solutions. It's like the same solution with the same operations, and it does. All you have to do is add this function basically to pixel, like to write pixels, and then like display your screen, and that's the only thing that changes, which is pretty cool. All right, sweet. Okay. Day 9, I am not going back to day 9 probably. There's like a bug in my it's basically a game of Snake, and there's a bug in my code that I can't figure out. It hurts my head, and I'm not going to do it right now. I might do it like tomorrow if I feel better. I'll go back to it. But there's also a new day, which is going to take me probably longer, or at least the same amount that it took me today. So I don't know. Anyway, there we go. Let's push this. But yeah, there's some cool stuff in here. I like the optics. So for her Hotzenplots, if you let me show you the optics. Like the optics are like this. So I think you've done optics in Haskell. I have no idea. Maybe Magic Mud has, not sure. But you basically have these companion objects that get written for you that are just your lenses. So this is a lens from execution state to CRT buffer, and then we write like modify or set or whatever, and you can modify the thing to update it. And this syntax is basically just uh, x to x like that. You can just short a single thing to it. Oh, my cats are ready for food, so we need to get going. Um, but yeah, I kind of like this. I hate this syntax a lot actually. So this says if signal strength is null, return this. If it's not null, then do this modification. But if this thing is also null, then return the result. So it's kind of like maybe, except that you can't return a null thing. Maybe in Haskell, I mean, like uh, Google, maybe. So if B was nullable, you could return a null, like a maybe B, but you can't actually do that with this chain of functions. So that's kind of something I wanted to write, but I think it's actually kind of tricky. Uh, it's not that tricky, I guess. But you what I really want is like I want maybe, but that's not really what maybe does. This one, the code we're looking. Also, hopefully I'll figure out this camera issue. Like I don't really understand the charging situation. Like, how do you recharge this battery with the cable? Like, why even give you a cable if it doesn't recharge the battery? That's like the dumbest thing I've ever heard. So the battery on my camera is dead. But I do have a new DSLR camera. Or sorry, it's a mirrorless camera. It's not DSLR. I think those things are technically different, but I don't fully understand the difference. Um, and we used it yesterday, and it was actually really, really nice. But I need to figure out how to charge it. Like, what? What do you mean the cable doesn't charge it? What the hell's the matter with you? Like, that's just like the dumbest thing I've ever heard. Why would you buy? Why would you sell me a product that didn't charge itself? I don't understand. Ugh. I'm just like staring at the camera right now. You can't see me, but I'm kind of frustrated. Yeah, it's I mean, you need to charge a camera, right? Like they have batteries. But oh, I see what you're doing. you're you're sarcasm is so hard right now. Um but yeah, like if if the cable just charged the camera, which like obviously it should, then we would have no problems. But I think what you're intended to do is pull the battery out of it and put that into like a charging device that goes into the wall. But n- no, like just straight up no. That's the stupidest thing ever. So anyway, this is the third cable I'm gonna have to buy for this camera because the first cable I bought was like it's basically a micro HDMI to HDMI. So the camera goes, it has two ports basically. It has a micro HDMI that you plug into a capture card and you plug that into your computer, right? So that's how you convert the output from the camera into like OBS output so that you can display to the screen. And it actually looked super good yesterday. So the camera is like actually pretty nice. However, the cable is too small to put the camera. It was too short. It was 6 feet, and apparently 6 feet is not enough. Like I don't know how the distance between here and here is more than 6 feet, but it is apparently. Or this cable is just like abnormally short. So I bought a 10-foot cable. So as long as I get a 10-foot cable, then it should 100% reach from where I had the camera originally to there. But now I need another cable that can charge this thing because this thing is not rated for that. Which also kind of explains why it was being so sketchy yesterday, like turning on and off and stuff. Like it's just not really designed to do this. So yeah, I don't know. I don't know, man. I'm confused. Very confused. I probably have a USB-C to A cable that charges somewhere around here. So I should just look for a cable before I buy one. Okay, anyway, I'm sorry. I'm just like straight up rambling at this point. I don't feel like finding somebody to raid because I'm too tired right now. So thanks for hanging out, everyone. Sorry I'm dumb and I don't know how what I'm doing 99% of the time. But we did finish this eventually, and so I'm pretty happy about that. Okay, bye bye.